This video is going to focus on the modular transmitter and receiver chassis options along with the modular transmitter and receiver cards for the DKM FX solution. What we see here is a 2-port, a 4-port, and a 6-port option for the modular cards. This is not to be confused with our compact transmitters and receivers, as they are all self-contained and do not contain any modular pieces or parts. With this being said, with these different 2, 4, and 6-port options, we also carry different flavors, such as ones that support redundant power inputs. We also support backplanes where you could slide a card in easily and everything is pretty much seamless. You don't have to take down the chassis to upgrade or replace a card. And we also offer a 12, 24, and 48 volt DC option for manufacturing plants or an aircraft or any type of vehicle use, places where you're not going to get the 110 240 volt AC input. So before we get too further into these chassis, I want to make reference to the old chassis compared to the new chassis. So on the old chassis, the non-R2, what we find is that the mounting holes on the side for the rack mount ears are located near the bottom of the chassis. The newer chassis that are in fact R2, the mounting holes are located in the center of the actual chassis. Now, between these two different styles, they'll use two different rack mounting options. The old version will use a shelf-like option for mounting, whereas the new version, the R2, will use a mounting ear or mounting L bracket. So Black Box will in fact configure and build all of the transmitter and receiver units that you order. However, in circumstances where you're building yourself or performing an on-site upgrade or replacement, you're going to need to know how to work on these yourself. So what you'll need is a Torx head that would fit the screws found on every single chassis. The screws that are going to be used that holds the lid together onto the chassis, along with the screws that hold the cards in place when you do install the cards, is going to be an M3x6 screw. You can usually find these at your local hardware store, or if you need spares, give us a call and we can send them to you. So before you start inserting the cards, what you'll want to do is remove all of the screws that hold the top cover on. On the 6-port, which we'll focus on right now, you'll find 3 screws on the top, here, 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 and 2 screws on each side of the chassis. Now obviously, when you're using mounting ears, you're going to put the mounting ear on first and then apply the screws. When you open the lid to the chassis, what you will see is an internal power supply, and then you will see some power connectors. We call these power jumpers. These jumpers will be plugged into any card that has a power connector, and they could be easily identified by finding the light brown connector. Now, cards that have 2 of these connectors, they are designed to send power in and send power out to another card. What you'll see in a 6-port chassis, for example, is 3 or 4 power connectors. Now when it's fully populated, you're going to need to use a jumper. These jumpers will then take power from a card and send it to another card. You don't want to cascade more than 2 cards or 3 cards because what you end up doing is drawing more current through in that type of setup. So it's always best to try to not make them daisy chained more than 2 or 3 layers. By the way, the power connectors, we see 2 on the board. Each one can either be an input or an output. It doesn't matter. It's all connected and soldered onto the same circuit. You'll also find that we have cards that do not have any power connectors. If you find a card that doesn't have any power connectors on it, what that means is that it will use a header that will interface with one of the main cards, and it will derive its power through the main card. Through this video, I'm going to refer to two styles of cards. There's going to be an interface card, which I donate as a card that has either an RJ45 or an LC fiber connector. There's also the second card, which is a daughter card. The daughter card will plug into an interface card, and it will usually take its power from that. There are some exceptions, such as USB 2.0 receiver cards that will require their own power because they would have to power up the remote USB devices. So interface card with a connector that goes back to the opposite extender or through the KVM switch, and then a daughter card. So what you'll first want to do is prepare your power jumper cables. In this chassis I have 4 jumper cables, and I want to build myself an extender. So what I'll do for video purposes and demo purposes is I'm going to install a DVI-I transmitter card and an HDMI receiver card. I'm also going to use a daughter card installation on, let's see, this would be a receiver audio card, and I can tell that it's a receiver card because of the part number, ACX1MR. If it's an R, it's going to be found on the receiver. If this is a T, it's going to be found on the transmitter. But I'll use this in this video just to show you how that all comes together. With the daughter card, you will see that on every interface card you have 2 header options. There's header 1 and header 2, or header A and header B. The daughter cards will connect to these headers to transfer data through the interface card. Now, since I'm using 1 out of 2 of these daughter card headers, you'll see I do have an option to set up a second daughter card. So I have RS-232, I have bidirectional analog audio, and now I can use either another card that would be placed on top of this interface card, or I can use a header jumper to go to another daughter card to maybe support digital audio or USB 2.0 or something along those lines. Every interface card can support up to 2 daughter cards, with the exception of the USB 2.0 card that is an interface card. I'll make note in the video about those part numbers. So let me get into installation. I'm first going to install the transmitter card. The best way to go about this is to take your card, since it's only 1 card at this time, plug it into the chassis, or at least lay it in the chassis. You'll notice there's a back shelf that would allow the board to slide in so it can remain stable. Once that's set in place, you're going to want to use your torque screws, the M3x6, and it's always easier once you get the back in to slightly lift the chassis up and hold the card, and then you can install the torque screws. Now, you don't want to tighten the screws too tight. This is all aluminum, so if you try to crank them down, you'll find that you will strip the threads. Great. So the first card's installed. I still need to apply power. What I'm going to do is take one of these power jumpers, plug it into the card like so, and now this card can be powered up. The next thing I'm going to do is install the receiver card. Obviously, the receiver card and the transmitter card would not be found in the same chassis, but in certain circumstances you will find this type of installation or this type of design, but for this video I'm going to use the same chassis. So I was talking about cascading power. For this video I'm going to show you a cascaded power connection. So I'm going to take this extra jumper, the power jumper I have, plug it into the spare connector, And I can now power up my second card. Now this is acceptable. I can also do it this way. I'm literally just switching these cables around, and I'm going to use the longer one since it's on the other side, and plug the jumper on the other side. These are agnostic ports. There's two of them, and they both can be an in or an out once again. So I'm going to power this card, and this is set. I'm going now to add the RS-232 and bidirectional audio card. I'm going to simply stack it on top of the interface card, and what you'll find is it's so much easier to place this in the chassis once these cards are mated together. So once it's firmly seated, I'm going to install it in this port. And you'll see that these back ledges are going to be a little bit easier to work with now that the cards are mated together. If I tried to add the daughter card after the interface card was installed, you're going to run into a lot more problems when trying to set that together. Now you'll see I'm kind of struggling here just a little bit, but there we go. So now it's in place, and I'm going to add my screws. Once again, just hold the cards in place, tip the chassis up, put the screw in place, and tighten it down. I'm only going to use 2 screws in this demo. If you're concerned about the screws becoming loose, if you're installing on maybe in a rack or cabinet or in a location where you have vibration, you might want to use Loctite or something to hold the screws in. If there's a lot of vibrations, these could potentially become loose. So now that I have this configuration, all I need right now to do a point-to-point extension is take a CADX cable, plug it into the transmitter, take the other side, plug it into the receiver, and now I have a KVM extender. Here's the transmitter, here's the receiver. Obviously, the receiver has a daughter card that supports RS-232 and bidirectional audio, and on the transmitter I don't have that card. So what you'll find is this card's pretty much useless because I don't have the opposite side. Anytime you're transferring data through a daughter card, the way that works is if you go in on daughter card header A, whatever is being connected to on the other side, it's going to come out on side A. If I plug it into B for the daughter card, the data on the receiver is going to come out as B. So if I put an audio card on the transmitter plugged into header B, and on my receiver my audio card's plugged into header A, the audio will never pass. I will never hear audio until I match those correctly. So now that we have a point-to-point extension, before you close your chassis up, we always want to just validate that all cards are getting power and everything has been installed correctly. So what I'm going to do is just plug the power in to the mains inlet. It'll take a few moments, but you'll find that most of these cards have onboard LEDs. This is a good sign. On the audio cards and some other daughter cards, they do not have any front status LEDs. So don't be concerned if there's no LEDs that are seen on the daughter card. If you're concerned about it, you can always confirm by either looking through the vent holes on the chassis or popping the lid and looking on the main board. If you see the LEDs, you're in good shape. The card is in fact powered. The LEDs for the interface cards can be found on the back or the front. This LED is the same as this LED. This is so, as a user, if you want to install your chassis, let's say this is the front of the rack or cabinet, you can install the mounting ears in such a way that you can see all of your connectors on the front and see the front LEDs, or you could flip your mounting ears around so you don't see all the connectors, but you do only see the LEDs. This is a pretty nice feature of the DKM. So at this point, you can put your lid on, insert the screws, put your mounting ears on, and put it in the rack, like so. And now you'll be able to see that the cards do have status LEDs. There are several variations of the colors to tell you whether USB is connected, video is active, a video is plugged in. The card, it'll tell you a little bit of information about the firmware. Also, when you connect a transmitter to a receiver, or a transmitter or receiver to a switch, there are several link lights that can be used to identify if you have a cable problem. So when you first turn the card on, if you have no link light, or the link light is solid green, and your status LED is solid red, this usually means that you have corrupt firmware. The exception to this is if you're using the USB 2.0 interface card. That will automatically turn on and show a solid red LED. Don't be concerned with that card. That's the only exception. So when I boot the chassis up, if I see a blinking red LED, since there's no DVI or USB input, this is a good sign. The flashing green link light is also a good sign, telling me that there's no connection and the firmware is good. At this point, I could take the connection, plug it in, and this LED should now turn to a solid green. If it does not turn to a solid green LED, you need to either check your cable or check the connection to the other side, whether it's going to the transmitter or receiver or to a switch. This is a good indication if you're going to have any type of interconnect problems. So this pretty much summarizes the modular chassis and the cards. Merle, do you have anything to add to this? Okay. Well, that's pretty much is it then. Thank you.